Let's learn about logs. No, not that type of log. Logarithms. It's alright, let's dive right in so I can explain more. In algebra, a log is the inverse function of an exponential function, and in everyday life it is used to find growth and decay rates, interest rates, and also comes up many times in science, for example, measuring sound intensity. A basic log looks like this. When reading a log out loud, you would say log base 4 of 16. I know it looks pretty cool and all, but the way you solve it is even cooler. Logs are like puzzles, and since logs are the inverse of exponents, you want to ask yourself the question, 4 to what power will give you 16? 2? Then log base 4 of 16 equals 2. You try. The answer is 5. Great job. If you have a log equation with a variable, for example, log base 6 of x equals 2, there's a fun way to solve it called the fishhook method. It's exactly how it sounds, a fishhook. You would write it like this. It's basically asking the same question as before. 6 to what power gives you x? But you already know that 6 squared equals x, so you can just write it as 6 squared equals x, so x equals 36. You try. Nice job. Now, there are some need-to-know rules in logs that are important to understanding logs and are especially helpful when you get more difficult log expressions. These include log base b of b equals 1, log base b of 1 equals 0, b to the power of log base b of x equals x. If b to the x equals b to the fifth, then x equals 5, ln e equals 1, and ln 1 equals 0. Something else that isn't a law but good to know is that if you have something like log 7, it may look like there's no base, but it's actually base 10. Now, you might be wondering, what exactly is ln? ln is the natural log with base e. E is a mathematical constant and is approximately 2.718. I won't go into too much depth with that here, but just be aware of what it is. There are even more essential properties that help simplify log expressions. The first two are called expansion properties, which is a way that you can split up or expand logs that may seem complicated into something more familiar. The first is the multiplication and addition property. Basically, if you have a log or natural log being multiplied, like xy, 7x, or 3y, it is the same as saying the log of each of those things added together. An example of this with real numbers would be ln of 7x equals ln 7 plus ln x. A very similar property applies to division and subtraction. If there is a log or natural log of something being divided, you can split each up and subtract them like so. ln of x over y equals ln x minus ln y. With numbers, it would look like this. Pretty easy, right? Another very cool property is the exponent property. It basically says that you can rewrite a log with an exponent as a normal log with the exponent moved to the front like this. Say you have log base 3 of 9 to the 4th equals x. It looks confusing because you have to find 3 to the x gives you 9 to the 4th, but there's a much easier way using the exponent property. If you move the exponent to the front, it can be written as 4 times log base 3 of 9. You already know that log base 3 of 9 equals 2, so all you're left with is 4 times 2, which is 8. So log base 3 of 9 to the 4th is 8. It's a super helpful property. The final property is the change of base. I know it sounds kind of scary, but it's really easy. This basically makes it easier to solve imperfect logs like log base 4 of 5. Instead, you would write it as log 5 over log 4. You might be thinking to yourself, well, why does this work? That is a great question, so let's walk through it together. So, you are trying to find log base 4 of 5, so set it equal to x. From there, you can use the fishhook method to get 4 to the x equals 5. X is what you are solving for. Since a log is the inverse of the exponent, you can take the log of both sides for log 4 to the x equals log 5. But wait, we know the exponent property. Since we have x in the exponent, we can move it to the front of the log equation for x log 4 equals log 5. Now all we need to do is simple algebra. Get x by itself and divide both sides by log 4. So x equals log 5 over log 4. The change of base property is just further proof of how important it is to know the other properties like the fishhook method and the exponent property. Wow, we have gone through a lot about logs in a really short amount of time. Let's do a quick recap. We first learned about what logs are and how they are used in the world. Do you remember what they are? They are the inverse function of exponential functions. Nice. Then we learned the most basic ways to solve log equations. What to what power will give me what? Wow, that's a lot of whats. Someone really needs to come up with something better. And we also learned the fishhook method. Then we got into the really fun stuff and learned about the different rules and laws that can be super helpful when solving log equations. So, didn't you have so much fun learning about logs? Yay! I knew you would! Now let's get into the unit circle. That's a lot of fun too. We can go do this and that and that and that and that and that and that.